Hello students, welcome to my class. In today's class, we will learn a new concept, class 10 circles. Example 1. The length of a tangent from a point A at a distance 5 cm from the center of the circle is 4 cm. Find the radius of the circle. So here we have a circle with the center O, and we have a tangent from an external point P. We have a tangent PA. The length of the tangent from a point A. So here we have given the point is A, and which is at a distance 5 cm. So the distance of this point A from the center is 5 cm, and we will take this tangent as AP. Then we have to find the length of the tangent is given as 4 cm. 4 cm is length of the tangent. Then we have to find the radius of the circle. So we have to find the OP length we have to find. So we have already seen in first theorem, the radius of a circle is perpendicular to the tangent. So this angle is 90 degrees. So triangle OAP is a right angled triangle. So we got here triangle OAP is a right angled triangle. So here we will use Pythagoras theorem. So the side opposite to 90 degree is OA. So OA, hypotenuse square, OA square is equal to PA square plus OP square. So here OA is given as 5. So 5 square is equal to PA is given as 4. So 4 square plus OP square. That is OP square is equal to 25 minus 4 square, that is 16, which is equal to 9. Therefore OP is equal to root of 9 is equal to 3 cm. So the radius of the circle. So we got now the radius of the circle. Therefore the radius of the circle is equal to 3 cm. Now we will see the next example. Example 2. Two tangents TP and TQ are drawn to a circle with the center O from an external point T. Then prove that angle PTQ is equal to 2 times angle OPQ. So you have to prove here angle PTQ. This angle is equal to 2 times angle OPQ. This is what we have to prove. So here we have given a circle with the center O and an external point T, and TP and TQ are the tangents from the external point T to the circle. Now we have to prove. So to prove, we have to prove here angle PTQ is equal to 2 times angle OPQ. This we have to prove. So first let us take this angle as theta. We will take this angle as theta. So let angle PTQ is equal to theta. Now we have already learned the theorem. The length of the tangents are equal. That is TP and TQ are equal. So these two lengths are equal. Since TP is equal to TQ, this triangle TPQ is an isosceles triangle. Triangle TPQ is an isosceles triangle. Isosceles triangle. So that means two sides are equal. Then the angle opposite to these equal sides also equal. So we will take this angle as x. So these two angles will be x. Now we will find out what is this measurement. That is angle TPQ. So we will take angle TPQ is equal to, we will take the sum of all the three angles is 180 degree. So we will take angle TPQ plus angle TQP, angle TQP plus angle PTQ. angles is 180 degree. So we'll get this as 180 degree. Now we have assumed TPQ and TQP as x. So here we will substitute. So x plus x plus this angle is theta. So theta is equal to 180 degree. That is 2x is equal to 180 minus theta. From that x is equal to 180 minus theta by 2. We can simplify this as 90 minus theta by 2. So this x is nothing but angle TPQ. So we got angle TPQ is equal to, that is x, that is equal to 90 minus theta by 2. Now from the first theorem we know the radius of a circle is perpendicular to the tangent. That is angle OPT. Angle OPT is equal to 90 degree. But what we need is angle OPQ. We will take from this, we will find out angle OPQ. So angle OPQ is equal to, from the full angle we will subtract this portion. So you will get angle OPQ. So angle OPQ is equal to angle OPT minus angle QPT. Angle QPT. Now this is 90 degree. We already got this is 90 degree and this is nothing but x. We have already got the angle as 90 minus theta by 2. So 90 minus theta by 2. Now we will simplify this. That is 90 minus 90 plus theta by 2. So these two will get cancelled and you will get angle. This 2 we will take to this side. So angle OPQ is equal to theta by 2. So we will take this 2 to this side. So we will get 2 angle OPQ is equal to theta. Theta is nothing but angle PTQ. So angle PTQ. So we got the answer. Angle PTQ is equal to 2 angle OPQ. Example 3. PQ is a chord of length 8 cm of a circle of radius 5 cm. The tangents at P and Q intersect at a point T. Find the length TP. So this is our question. So here we have a chord PQ of length 8 cm. So the length of the chord is 8 cm and the radius of the circle is given as 5 cm. So the radius OP is the radius. So this length is 5 cm. And the tangents at P and Q intersect at the point T. Then you have to find the length of the tangent, that is TP you have to find. So we will take this length as x. So we will take let TP is equal to x. We will take. Now if you see, since this triangle PTQ is an isosceles triangle, because you know that the length of the tangents from an external points are equal. So in this triangle TP and TQ are equal. So this triangle is an isosceles triangle. So if you join the points T and O, then the line OT bisect the chord PQ. So this will bisect the chord PQ. So this length will be, so if you are taking this point as R, then the length of PR will be 4 cm because the chord length is given as 8 cm. Length of the chord is 8 cm. So PR we will get as 4 cm. Now if you consider this angle is 90 degrees, so we will consider triangle OPR, which is a right angled triangle. So using Pythagoras theorem, we can find the length OR. So in triangle OPR, we have to find OR length. So OR is equal to square root of, here the hypotenuse is OP. So OP OP square minus PR square. That is equal to root of 5 square minus 4 square. That is 25 minus 16 is equal to root 9, which is equal to 3. So we got now OR length as 3 centimeter. Now we will consider this triangle TPR. We will consider this triangle TPR. This is also this is also an isosceles right angled triangle. So here we will take this length TR as Y. So we will consider the next right angled triangle TPR. So here also we will use Pythagoras theorem. So we can write x square is equal to x square, hypotenuse is x here, this length only. So x square is equal to TR square plus PR square. That is y square plus 4 square. This is the first equation. The same way, next we will consider, you know that the radius of a circle is perpendicular to the tangent. So this angle is also 90 degree. So triangle OPT is also a right angled triangle. So triangle OPT. So now we will consider this right angled triangle OPT. Here we will use Pythagoras theorem. So we can write here x square. So this is TP square, that is x square plus PO square. PO square is 5 square, which is equal to TO square. So what is TO here? The length TR we have taken as Y, and RO we already got. RO is 3 centimeter. So TO, length TO is Y plus 3. So we will get Y plus 3 the whole square. This is the second equation. Now we have to subtract the first equation from the second equation. So we will simplify first the second equation, that is x square plus 25 is equal to, here we will expand using a plus b the whole square identity. So y square plus 6y plus 9. So this is our second equation. Now we will subtract this first equation from the second one. So x square is equal to y square plus 16. If you do subtraction, these terms, that is x square term will get cancelled and y square term also will get cancelled, and what is remaining, 25 is equal to 6y, 9 minus 16, that is 7. So 6y minus 7. From this we will find the value of y. So 6y is equal to 25 plus 7, that is y is equal to 32 by 6. So here we will get y is equal to 32 by 6. This further we can simplify, that is 16 by 3. We will get y value as 16 by 3. Actually we have to find the length of the tangent, that is x value only. So this y value we will substitute in first equation. So here we have the first equation as x square is equal to y square plus 4 square. In this first equation, we will substitute the value of y. That is x square is equal to y. In the place of y, we will substitute a 16 by 3. So 16 by 3 the whole square plus 4 square. 4 square we will write as 16. Now from these two terms we can take a 16 outside. So the first term we will have a 16 by 9 plus 1. So from these two terms we are taking 16 outside. So we will get this expression. This is nothing but 16 into 16. When you simplify the expression inside the bracket, we will get 16 plus 9 by 9. That is 25 by 9. We will get 16 into 25 by 9. This is the value of x square. So we have to find the value of x. So we will take the square root now, that is 16 into 25 by 9. That is equal to 4 into 5 by 3. We will take the square root of each of the number. So 4 into 25 square root is 5 and 9 square root is 3. So the answer is 20 by 3 centimeter. That is the length of the tangent TP is equal to 20 by 3 centimeter. Thank you, students.